Subset of B if all of the elements of A why am my pen doing that? Okay, so all of the elements in A are also in B. So you indicate A is a subset of B, like that. Okay? So this symbol means is a subset. If you put a line through it, it is not a subset. Okay? So an example of a subset. If you had a set that were all of the digits 1 through 10, right? So I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The even numbers would be a subset. The even numbers up to 10. Because 2, 4, 6, 8, and 10 are also in the numbers 1 through 10. Does that make sense? Okay. We're going to decide if A is a subset of B. So I look at the elements in A. So 1 is also in B. 3 is also in B. 5 is in B. 7 is in B. So it is a subset. It's just if all of these numbers, and it has to be every single one. No numbers can be missing.
How do you fill that out? How do you fill that out?
So like here I say 1, 3, 5, and 7, right? So since this is A, is 1, 3, 5, and 7, I have to look in B and make sure that all of these are also in here. So it's a matching game. Okay, so here I have X, such that X is a letter in the word proof. Okay, so in the next set I would need P, R, O, O, and F. Well, B is Y, such that Y is a letter in the word roof. I'm missing the letter P, so it's not a subset. So they have to match. They don't have to match as in to be equal. The subset is usually much smaller than the set. Sometimes they are exactly equal though. But they have to match in that everything in A also has to be in B. All right, so proper sets, okay? If we have X such that X is a planet in the solar system, that's A, and we want to know if that's a subset of B. And B is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and unfortunately no longer Pluto. Makes me sad. Okay, so yes, these are all the planets in the solar system. This says that it has to be a planet in the solar system. So it is a subset. But they're also equal. Whoa. All right. That makes this not a proper subset. A proper subset occurs when A is a subset of B, but A is not equal to B. Okay, that's a proper subset. And you symbolize a proper subset like this, without the line underneath it. Okay, so when we had that last page where you had 1, 3, 5, and 7, and then B was 1, 3, 5, 7, 9, and 11. In this instance, A is a proper subset of B because A is a subset, but they're not equal, right? Because B also has 9 and 11. So this is a symbol for proper subset. We're going to use the symbol subset, proper subset, or both to form a true statement. We're not going to use the both. We're just going to use subset or proper subset. So X such that X is a person and X lives in San Francisco, or X such that X is a person and X lives in California. Okay, so A, San Francisco, where's San Francisco? California. So if you live in San Francisco, you also live in California. So A is a subset of B. Oops, sorry. A is a proper subset of B, right? Because if you live in California, it doesn't mean you live in San Francisco. You could live in LA, you could live in Napa, you could live in San Diego, you could live in some little podunk California town nobody ever heard of, you know? So this is a proper subset. Here we have A is 2, 4, 6, and 8, and B is 2, 4, 6, and 8. So A is a subset, but it's not proper because they're the same size. All right, so when we talk about the empty set, nothingness is a subset of everything, right? Because if you have everything, there's also nothing kind of in the spaces in between, I guess. So the empty set is a subset of all sets. So the empty set is a subset of all sets. And remember how yesterday we discussed that the empty set is not an element unless it's actually listed. So the empty set is not an element of all sets unless it's listed, but it is a subset of all sets. And so you could say it's a subset of B, and it's a proper subset of B if B is not the empty set. Okay? So as long as B has something in it, the empty set is a proper subset. Okay. Now, here, if I have an empty set, I have no elements. I have one subset, that's also the empty set, so my number of subsets is 1. If I have a set that includes just the letter A, there's one element in it. The subsets are the empty set in A, so that gives me 2 subsets. If I have a set that has A and B in it, I have 2 elements. My subsets are the sets A, B, AB, and the empty set. So I have 4 subsets. And then if I have a set that has A, B, and C, that has 3 elements. And I have the subsets A, B, and C, and the empty set. I also have AB, AC, BC, and ABC. So I have 8. Okay, so the number of subsets with n elements. So basically I take any n, this n right here, just stands for how many elements there are. 2, 5, 3, whatever. To find out how many subsets are in that set, I take 2 and I raise it to the power of however many elements were in the set. Okay? The number of proper subsets then would be 2 to the n minus 1. And the -1 comes from, I'm going to back up for just 1 second. If we look here, each of these included itself, so we're subtracting that one away. So we take itself away and make it, because that's not a proper subset. So to find the number of subsets, you count how many elements are in it, and that's your exponent on a 2. So we'll go through the powers of 2. If I raise 2 to the power of 0, that's 1. And if you remember, our empty set had 0 elements, but it had one subset, which was itself. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the third is 8. And see, here's that third column. We had 1, 2, 4, and 8. 2 to the fourth, 16. 2 to the fifth, 32. 2 to the sixth, 64. 2 to the seventh, 128. 2 to the eighth, 256. 2 to the ninth, 512. 2 to the 10th, 1024. 2 to the 11th, 2048. 2 to the 12th, 4096. Bless you. 2 to the 13th is, sorry, not 2 to the 13th, I'm skipped. 2 to the 15th is 32,768. 2 to the 20th is 1,048,576. So as you can see, it gets really big really fast, and that's because you're just doubling it every time you multiply by 2 again. So how many subsets are in a set with 10 elements? You find the exponent 10. There would be 1,024 subsets. Would I expect you to list them all? Absolutely not. Now, okay, we have sets and we can do Venn diagrams to do set operations, okay? And so the universal set is a general set. General. Okay, so the universal set is the general set that contains all of the elements that are being considered. So think of it like as the B in the A and B subsets. It's the bigger set. It contains everything. Okay, a Venn diagram was discovered or developed by someone whose first name escapes me right now, but their last name was Venn. And it's just a visual relationship among sets. And it uses circles and rectangles. Okay. This U stands for the universal set. So the universal set is symbolized with a U. Okay, and then this A is this set here, A. So as you can see, if U is the universal set, A is inside of U, A is a subset. So we draw the subsets inside of each other. Okay. So U is the set that includes M, $, 5, square, and triangle. Because that's every single thing that appears in this rectangle. Right? We have M, square, triangle, $, and 5. A is the set that includes square and triangle. That's the only thing inside the circle for A. And then the set of elements in U that are not in A, well, that's everything that's outside of the circle. So that's $5. So there are four kinds of ways to draw a basic Venn diagram with two sets. So first, I want you to draw a couple of rectangles. Okay. And if it's easier to label the U on the outside so you don't think of it as being part of the set, you can do that, or you can just put it up in this top corner, because that's U for the universal set. Disjoint sets, so if I have two subsets inside of U that are disjoint, they're not going to touch. And this would be set A and set B. Proper subsets are going to look like this, where one of them is inside of the other. So maybe that's A and that's B. Equal sets. You only have one circle and A equals B. And then you have some sets that have some common elements. This is probably the Venn diagram you guys are most familiar with seeing before, where the circles overlap. So it's not exactly a subset situation, but they have some things in common. Okay, so what we have, these Roman numerals, 1, 2, 3, and 4, these indicate regions. Region 1 is only in A. Region 2 is in A and B. Region 3 is only in B. And then region 4 is not in A or B. So these are regions. So we're going to ignore the Roman numerals as far as elements of the set. They're not elements of the set. They're just, so you can say, okay, these elements that are in here are only in A. These are in both A and B. These are only in B, and these are not in either. Okay. So if we use the Venn diagram to determine each of the following sets, well, U is the whole box. So U is every single thing inside here. So that's A, B, C, D, E, F, and G. Okay. B is this circle. So that includes the overlap and the part that's only in B. So B is D and E, right? Because that's everything that's inside this circle. Sets in A but not in B. Okay, well, A would be all of this. But we don't want the part that's in B. So we're just going to use like the moon, right? Yeah, so it's A, B, and C. Okay, we have sets of element in U but not in B. Well, U is the box on the outside, but U is also A and B. So we want everything that's not, yeah, take everything that's just not in this circle. So it's going to be A, B, C, and then F and G. And then the set of elements that are in both A and B, that's just this little overlapping part. So that's just D. Okay, the complement of a set. So if we have set A, the complement would be A prime. So A with a little apostrophe after it. Okay, and that's all elements in the universal set. Okay, so if you're looking for A prime, that's what you call it, A prime. You take everything that's in the whole box and eliminate the elements that are in A. So it's everything that's not in A. If we were to go back to our original drawing on the last page, it would be E, F, and G, because you just ignore the ones inside the circle for A. Okay, so if you're given a list and you're asked to find A prime, there's two ways we can do it. Okay, method one, I can write down the universal set. And then I can take and I can look at A and I can start crossing out all of the elements that are in A. And that gives me A prime, whatever's left. So 2, 5, 6, 8, 9. Or I can make a Venn diagram. Okay, this will be U, this will be A. And I can start, okay, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then A prime is everything that's not in the circle. Okay, intersections of a set. The symbol for an intersection is like an upside down U. Okay, and this is the set of elements common to both, if you had sets A and B, so it would be common to both A and B. In our Venn diagram, that's this part right here, where they overlap. That would be the intersection. So what you do to find the intersection of a set, you're looking for elements that are common to both sets. Is that fair? Okay. So I have an 8 and an 8 and a 10 and a 10. Nothing else matches, right? So my intersection is 8, 10. Over here I have all odd numbers, and here I have all even numbers. So they have nothing in common, and the set that symbolizes nothing is the empty set. And again, you can use this symbol, or if you want, you can do set brackets with nothing in them. And then here I have odd numbers and the empty set. Anytime you intersect with the empty set, you're intersecting with nothing, so you get nothing. So if you intersect and get no matches, this will always be your answer. Okay. Intersections use the word and. So an example of that would be x such that x is an element of A and x is an element of B. And what that equals is A intersects B. What's a union? And two things come together, right? So a union that uses a right side up U, it uses the word or instead of and it's all elements in set A and all elements in set B. I can't hardly write today. Okay, now, each is written only one time. So if you have a 2 and A, and then you also have a 2 and B, you just write down 2 once. You don't have to write it twice. And the symbol for this would be X, such that X is an element of A, or X is an element of B. And that's A union B. Okay, so we find the union of two sets. We list all of the elements in both sets. So I start 6, 7, 8, 9, 10, 11, and 12. Right, because I have a 6 here, a 7 there. They both have an 8. 9, they both had a 10, and then 11 and 12. And these are the same sets that we intersected, but now we're uniting them. So here I have odd numbers and even numbers. So I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now if I intersect with an empty set, I had nothing. But if I unite with an empty set, I just get the elements from that set that had something in it. Okay. So just to recap, if you intersect with the empty set, you get the empty set. If you unite with the empty set, you basically just get yourself back. So this is sort of like multiplying by 0, and this is sort of like adding 0. Set operations. When you perform operations on sets, basically you're performing unions, intersections, and complements. That's really the only thing that you can do to sets. You kind of use the same general order of operations as you would with normal addition, subtraction, multiplication, and division. So you do what's inside the parentheses first, and then you work your way out. So here I have the complement of A union B. So before I can find the complement of A union B, I have to know what A union B is, and then I can take the complement of that out of the universal set. So first I find A union B. It shouldn't have a stick on the U, but whatever. Okay, so I have 1. They both have a 3. They both have a 7, and then I get an 8, a 9, and a 10. So that's A union B. Yes.
Okay, I have a question.
Okay. So A union B complement or prime. So I have 1, 3, 7, 8, 9, and 10. So I don't want to use this 1, but I can use the 2, not the 3, but I can use the 4, the 5, and the 6, and then not 7, 8, 9, or 10. So these are all of the elements in U that are not in A and B. Parentheses. So I have A prime union B prime. Before I can unite A prime and B prime, I have to know what A prime and B prime are. So first I'm going to find A prime. So A is 1, 3, 7, and 9. So from U, I have to get rid of 1, 3, 7, and 9. So I can do 2, 4, 5, 6, 8, and 10. So that's all of the numbers. Take away 1, 3, 7, and 9. And then I have to find B prime. B is 3, 7, 8, and 10. So I take away everything that's 3, 7, 8, and 10. So I have 1, 2, 4, 5, 6, but not 7 or 8. I do have 9, but not 10. Then I can unite them. And again, when I'm uniting them, I just write down all of these elements without repeating any. All right, so we'll go to the next one then. We can use a Venn diagram to do the same thing, and it's actually somewhat simpler. This is that Aleph symbol, so this is 2 to Aleph 0. All right, so if I do A union B, that's everything in both of these circles. Okay, I didn't give us enough room. Sorry about that. Pi, e, which is the base of the natural logs. Square root of 2, that's an irrational number. Square root of negative 1 is an imaginary number. E to the I pi, that's Euler. That means that equals 0. 10 to the 100 is a googolplex. Google, that's where they got their name. And then this is actually infinity, too. Okay, so if we had A union B was everything inside both of these circles, A union B prime is everything that's not in the circles. So that leaves infinity and Avogadro's number. How many of you have taken chemistry? Okay, then that should look a little bit familiar to you. That's the number for a mole. Okay, A intersect B, that's right here where the circles overlap. So that's the square root of 2, the square root of negative 1. Not A intersect B, so A intersect B prime is everything that's not in that little part. we talked about the cardinal number is the number of elements in the set, right? So the cardinal number, just as a refresher, is just number of elements. Okay? And there's a formula to find the cardinal number of the union of two sets. Because you can't just add up the two cardinal numbers. Like if one element or one set has 5 and another has 3, you can't say it's 8 because maybe 2 of them overlap. And so that's what this takes care of, is the overlap. So the cardinal number of the union is the cardinal number of A plus the cardinal number of B minus the cardinal number of the intersection. So we'll put that in 2 words. So this is the number of elements in A union B. Okay. This is the number of elements in A, number of elements in B, and we're going to subtract from that the number of elements in A intersect B. Okay. So there's a campus blood drive survey that shows that 490 students were willing to donate blood. 340 were willing to serve a free breakfast to blood donors, and 120 were willing to do both. Okay, if you're willing to do both, that makes you the intersection, right? Okay, so if we let set A, actually we'll say the cardinality of set A, we'll say that they're the blood donating students. So there's 490 of them. And set B is the people that would serve the free breakfast. So there were 340 of them. And the intersection had 120 students in it, right? Because there were 120 willing to do both. So now if I want to find out how many students are willing to donate blood or serve breakfast, remembering or is a union word. So I want to find, that's not M, I want to find how many are union. So that's N of A plus N of B minus the intersection. So that's 490 plus 340 minus 120. So there are 710 total students willing to help out, whether they're donating blood or serving breakfast or both.